Welcome to this video. This is Unzadani. In this video, we are going to talk about the oxygen dissociation curve. The oxygen dissociation curve, it illustrates the ability of hemoglobin to bind to oxygen and be able to load it to the tissues where they are needed. Ability of hemoglobin to bind and to unload oxygen to tissues. So the the oxygen dissociation curve is characterized by sigmoidal shape. Sigmoidal shape is just the S shape. So let's draw the oxygen dissociation curve so that you are able to see exactly what is happening. Yeah, so this is the curve. We draw the y-axis and then we draw the x-axis. So let's use the radical. So this is the y-axis and this is the x-axis. So this side, it's the saturation level of hemoglobin with oxygen. So we're going to say S saturation, then oxygen. Then down here, we're going to put the arterial partial pressure of oxygen. Then we're going to draw the sigmoidal shape that we talked about. It moves like this it goes. So as you can see from this curve, increasing the y-axis, that basically means that you are going to increase the saturation level of hemoglobin to oxygen. So this means that saturation level increases. So you find that here at the top it's 1.0, which is just the percentage for this side. So here we're going to write 0.5. Then here it can start from 20, 30. It goes till it reaches to like 100. So we are going to say when you shift this curve to the left like this, let's say this is hemoglobin, normal hemoglobin. when you shift the curve to the left, let's try to shift it. So you are going to see that this is left. This is left shift. So you're going to see that when you shift this curve here towards the left, you're going to see that the y-axis increases. And what does it basically mean when you increase the y-axis? It basically means that you increase the affinity of hemoglobin to oxygen. So that basically means that the oxygen will bind more to the hemoglobin. But what does it mean when you shift the curve to the left? Like this. You shift it to the curve. So as you can see, this curve here comes down and you reduce the y-axis. So when you reduce the y-axis, that means that you reduce the affinity of hemoglobin to bind oxygen. So now let's see the factors that affect the shifting of the curve to the left or to the right. So let's start with the left shift. Let's use a different color here. Let's use yellow. So firstly, what does it mean? How is the affinity of hemoglobin to oxygen when you shift this curve to the left? As you can see here, you increase the affinity. So we are going to write high affinity. High affinity. So what else? So when you increase the affinity, that basically means this is happening in the lungs because you have more oxygen. So in the lungs, let's rub this. So this is happening in the lungs. So in the lungs, you find that there is more oxygen than carbon dioxide in the lungs. So we're going to say decreased carbon dioxide. This is decreased carbon dioxide. And the decrease in carbon dioxide, that basically means the pH, or let's say the hydrogen ions. There will be a decrease in hydrogen ions. Decrease in hydrogen ions. And the decrease in hydrogen ions means that the pH is low. So this is low pH. So what other factor? So we have low 2,3/4 grace rate, which is shortens as 2,3-BP-G. 2,3-BP-PG, which is 2,3/4 grace rate. So let's also now consider the factors that affect the shifting of the curve to the right. So right shift. So when you shift the curve to the right, that means you are going to decrease the y-axis, and that means low affinity. Low affinity of hemoglobin. And when you have low affinity, that means that is happening in the tissues. In the tissues. So what do you find in the tissues? So in the tissues you find a lot of carbon dioxide. So increased carbon dioxide. An increase in carbon dioxide will affect hydrogen ions. How does the carbon dioxide affect hydrogen ions? So carbon dioxide, when is increased, it will increase the level of hydrogen ions. And how does this happen exactly? So this happens because this carbon dioxide here, it will combine with the solutions to produce carbonic acid. Carbonic acid. And this carbonic acid, it will dissociate into bicarbonate. Bicarbonate plus the same hydrogen ions that I talked about. So increase in hydrogen ions, it means high pH, I mean low pH acidity. Low pH, that means the pH becomes more acidic. And the other thing is increase in 2,3 biphosphoglycerate. 2,3 biphosphoglycerate. So this is all about this video. I hope you've understood how the shifting of the curve to the right or to the left happens.